In this video, I'm looking at the application problems at the end of our 6-1 guided notes. So let's take a look at question number 15. So we had these two baseball teams interested in signing a pitcher, right? So one team has already made an offer. And then the agent was communicating to the other team and told them that they needed to double that offer and add an extra $1 million per year, and then the team would be presenting an offer that they were interested in. Okay, the player is seeking a contract of $18 million per year. So we want to find out what was that first team's offer. So let's let X be the first team's offer. We don't know what it is. That's what we've got to figure out. What we do know is that if they were to double that and add $1 million, so double the offer and add, and I'm just going to use 1 instead of 1 million, so my answer will be then in millions. So if they double that, that means 2 times X, and add 1 million, then that's supposed to be an offer that would be what the player was interested in, or the player's agent was interested in, and we know the player is seeking a contract of $18 million per year. So this should equal 18. All right, so then we can solve that. So we can subtract 1 and get 2x equals 17, and then divide by 2, and we wind up with 8.5. So the first team's offer must have been $8.5 million. And then if they double that and added 1, okay, the other team, if they wanted to have the player sign with them, would then be offering $18 million. Okay. All right, so on that problem, I just let X represent the first team's offer, and then I was able to look at what the other team's offer would be by translating that, double that, and add an extra $1 million, translating that into 2x plus 1, and I knew that that would need to equal 18, so I was able to then just solve the equation. All right. So there may be 2 unknowns in a problem. But if we can represent one unknown in terms of the other, we can keep it where our equations will only have a single variable in them. Okay. So the example I put here is, if you know that one number is 5 more than another number, and we let the first number be x, then the second number could be represented by x plus 5, because 5 more than that first number. Right, and that's kind of what's going on in 16a. So we have 2 quantities. We have Donna's height and Christina's height. Right? So we're going to let X represent Christina's height in inches. And if we know Donna is 5 inches taller than Christina, then we know Donna's height would have to be whatever Christina's height is plus 5. Okay. All right, now let's try that with B. So we have X representing Ariana's test grade. Then we're trying to come up with an expression for John's, and rather than using a different variable like a Y, we could actually write an expression in terms of X for that. And it comes from us taking this right here and translating it. We want an expression for John's test grade. Well, we know his test grade is 5 points less, so we know it's 5 points less than Ariana's, than twice Ariana's. So if Ariana's test grade is X, twice that would be 2X, and 5 points less than that would be 2X minus 5. So 2X minus 5 would be an expression I could use to represent John's test grade. Okay. All right, now we've got 3 more problems that I wanted to look at. 17, and then the next one, which I just numbered these wrong. 16, I'm going to renumber it to 18 and 19. Okay, so 17 and 18 are really the same exact problem in a way. All right, there were a lot of mistakes in thinking on this one in class. I think drawing a picture can help. So the board is 6 feet long, and we're going to cut it into 2 pieces, but it didn't say 2 equal pieces. In fact, we know they can't be equal because one piece is going to be 3 times as long as the other piece. So one piece has to be longer, right? So just cut your board, just draw a mark that's not halfway, but off to one side. If I let X represent the length of the shorter piece, so that would be this, then I could write an expression for the length of the longer piece by thinking about the fact that the longer piece is 3 times as long as the shorter one. Okay, so the longer piece is 3 times as long as the other one, so I could use 3x to represent the length of the longer piece. And then the picture pretty much tells you what your equation would be, because the shorter piece plus the longer piece would have to equal 6. Okay, I'm going to come over here to solve it. So 4x would have to be 6, and if I divide by 4, that gives me that x would have to be 3 halves, which is 1.5, and the units on this were feet, 1.5 feet. So think about that. That means this piece was 1.5 feet. Okay. So then they want us to get the length of each piece. So to get the longer piece, I just need to do 3 times that. 3 times the 1.5, and that would give me 4.5 feet. Okay, so this would have to be 4.5 feet. And then notice if you add 1.5 and 4.5, you get the 6 feet that you're supposed to have. So we kind of check it by doing that. So they wanted the length of each piece. You would be able to say one piece is 1.5 feet, the other one is 4.5 feet. Okay. Now 18 is really just like that in a way. Okay. So the height of the deck is going to be 92 inches. It calls for support posts of 2 different heights. Okay. The taller ones are 8 inches longer than the shorter ones, and the sum of the lengths should be the height of the deck. Okay. So the longer one plus the shorter one would have to equal the height of the deck. Okay. So if I wind up letting the shorter one be x, and again, this would be, now in this case, it would be in inches. So I'm going to let x represent the length of the shorter one. Then if I know the taller ones are 8 inches longer than the shorter, then I know the longer ones would be x plus 8. And I know the sum of these lengths should equal the height of the deck. So then my equation becomes 2x plus 8 would have to be 92. And then I can just use the equation solving process to finish this. So I'm going to subtract 8. Okay, that would give me 2x would be equal to, what is that, 84? And then I would divide by 2. Let me move it up a little bit. 2x would equal 84. So if I divide by 2, x would equal 42, and the units would be inches, since this was inches. Okay, and that would be the shorter post. And then the longer one would be 8 more than that. So I would just add 8 to that and get 50 inches. And then my check would be that those two added up do equal the 92 inches they're supposed to. So my answer would be 42 inches and 50 inches. Now I wanted to look at question number 19. I gave you a question similar to this on the test. You know, we were doing problem solving on our test. Let me get a little more paper here. Okay, we were doing problem solving on our test, and we were able to just use any common sense procedure we wanted. Okay. All right, so let's do this one using a common sense procedure like you would have done on the last test. So we have a total amount of $137 in tips. All right, it's composed of $1 and $5 bills. So we can do a trial and error approach, trying to figure out, our job is to get how many of each type of bill did she get. And so we know some things about it. So you might just on this one do a trial and error approach where you might just be trying some stuff like, all right, well, let's see. What if she did 20, had $25 bills? Okay. Well, if she had $25 bills, it tells us that she got 53 more ones than fives. So 53 plus 20, that would be 73. So then let's calculate how much that would be and see how close it is to the 137. So 73 times the 1 plus 20 times 5 would equal $173. So it's too much. So I need fewer fives and more ones. So let me drop this down maybe to 10 fives. If it were 10 fives, then it would be 63 ones since she got 53 more singles than fives. Okay, so then I could calculate how much that would turn out to be by doing 63 times 1 plus 5 times the 10. That would be 50 plus 63. So that would be $113, which is too little. So that means I need more fives. So let me go to 15 fives. Okay, if I did 15 fives, then 15 plus 53, or 68, would be the number of ones. And if she had 68 ones, 68 times 1 would be the amount, how much that would be worth. 15 fives, so 15 times 5 would be how much that would be. Let's see what that turns out to be. So that's 68 plus 75, and 68 plus 75, that turns out to be 143, so we're getting close. But it's too much. Remember, our goal is 137. So let me do fewer fives, okay. 53 added to that would be 67, okay, 53 more. Did I do 53 more? Yeah, that's 68. Okay, and then that would be $67 plus $70. And 67 plus 70 finally gives us the 137. So we could do that kind of guess and check approach. So this was too high, so we jumped down. This was too low, so we needed more fives. This was too high but close, so I need fewer fives, and I just went down a little bit and wound up getting, this was the right one. And then the question on that one was, how many of each did she get? So she got 67 ones and 14 fives. Okay, so that would be an valid approach, right? That would be a trial and error approach. But now we've been working on using some algebra to help us with things, so we're going to try that here. Okay, so if we're going to use an algebra approach for this, what we would do is a little bit different. Okay, we might let X represent maybe how many fives she got. Okay, so let's do that. So let's let X be the number of fives. Okay, then remember how it said she got 53 more singles than fives? Then X plus 53 would be the number of singles, of ones. And then we know the total amount of money she received in tips was 137. So if she had X fives, they're worth $5 each. And then she had X plus 53 ones, they're worth $1 each. So that should total to be $137. And now we have an equation that we can solve. So 5x plus 53 has to be 137. These are like terms, so 6x plus 53 would be 137. So I could take away the 53, and see, I'm not thinking about the context anymore. Okay, once I've assigned and represented the quantities with x and x plus 3 and written this equation right here, then I can let the context leave my mind and just do that algebraic process real quick to get to the end of this. And so 6x winds up being 137 minus 53, which is 84. And when I divide both sides by 6, I wind up with x equaling 14. Then I have to go back and look what that 14 was. So remember, we had 14, x being the number of fives. So she would have gotten 14 fives, and then we know that she had 53 more ones, so we would add 53 to that and get 67 ones. And they wanted how many of each she got, so you would say 14 fives and 67 ones. Okay. So that last problem, I wanted you to look at the approach that's trial and error based, more like our problem solving before we did any algebra, and then what your approach could be once you get used to mathematizing a situation and using those variables to come up with an equation that connects the quantities in a problem.